Hey guys, what's happening? Hope everybody's good. Hope everybody's good in there. Can I get somebody to give me a 5 for 5 and we'll go ahead and rock and roll this little lizard thing we got going now. Going now. Alright. Hey, what's up, everybody? 5 for 5. Okay. So guys, you guys know my new format, guys. I am going to do the space weather like right now, and I'm not giving any shout outs or any of that stuff. Might say hi to some people as they're filtering in, but that would be it. Like this. What's up, Russell? Hey, Miss Dragon, good to see you. Who else was in here? Yeah, no, I'm not going to do that. Just kidding. Hey, Miss Herman. Good to see you guys. Okay, so what do we got going on, guys? We've got more flaring. As you guys seen the thumbnail, we've had 7 M-class flares. That is something that's a little bit nuts in the past couple days. Not only did we have M-class flares, we had an X-class flare that I showed you guys yesterday. I spoke about that at pretty good length, actually. So yeah, that's the big story. And yesterday, guys, if you remember right, I was telling you guys that I wasn't sure if the CMEs were actually going to come our way. Now I can say, hey Arizona, I can say without question that some of them are. Okay. Not only do we not have that one sunspot that's now rotating off, we have one that's rotating on that is huge. It's a big sunspot. It's one of the biggest ones we've seen in quite some time. And last time I looked, it had 12 separate cores. Okay. And it was like 130 kilometers long. That is huge. Okay. And I'll show it to you guys here in just a minute. But I do want to point out, this is the geomagnetic storm I showed you guys yesterday. Okay. Notice again, another one. Now these are short-lived. Now this is kind of what we were kind of expecting. If you go back and look at the forecasting on NOAA, they forecasted this stuff just to be a little bit higher than what it was, and their timing was off a little bit. But what did happen was we did get the solar wind stream from the coronal hole, and we did get hit with the CME. It just, it was a little bit more of a more sideways glancing blow than what they thought it was going to be. And there's a lot of other things that were going on there too. Our magnetic field actually went positive for a few minutes too. That kind of blocked things a little bit. That's the angle that I talk about, the BZ. And we'll go into that a little bit too. It went to the positive side, which means it was facing north more than so than south. When we're in a southerly orientation, things come into our system easier. So yeah, that's what's been going on. Now, as you can see here, guys, look at this. This is just non-stop flaring stuff. And these aren't little flares either. Now remember, when we're talking about flares, we're talking about X-ray, right? This is not a CME. Oftentimes with these bigger flares, there is a CME. And there was, and I showed you guys quite a few of them yesterday. But when we're talking about flares, we're talking about radio blackout conditions, right? Because it's X-ray. And it gets here in 8 minutes, the X-rays do. But there is something called, the shock wave actually gets here before that, believe it or not. It's almost instantaneous. It's quick, right? To be honest with you, I don't really know the whole science behind how that gets here before the X-ray does. But we've seen that a few times. I've seen other people talk about it also. And it's hard for us to pin down a pinpoint start time, but it's real close to the 8 minutes that we talk about. Light takes light 8 minutes to get here from the sun because it's moving at the speed of light. And X-rays are moving at the speed of light, so that's why it gets here. But we've noticed that a few times we've seen shock waves that seem to hit earlier than that. Now, I don't know if that's actually completely accurate, right? And let me show you why, okay? Because, we can go down, if you want to really get down to specific, like 8 minutes. You guys want to get down to that 8 minute specific to see when something, like when what we're talking about here, it has to be kind of precise, right? Well, the tools that I have, I don't really have that precision. So it's hard for me just to say that, right? And what I mean by that is when you go look at these tools, right? So if I want to say, let's just say this is the X flare yesterday. That one. I think that was the X flare. Yep, that was the X flare. So let me blow this up a little bit so I can explain to you guys what I'm trying to say. Okay. So if we look at this and we want to pinpoint exactly when that thing fired, I'm going to back this up. Okay. So if I wanted to say, hey, I want to start time for this flare, I would probably start right there. You see that? I'm talking about this little bit of a brightness that kind of happens there. Or you could go to that. Okay, that definitely would be the start of something there, right? So if you look at the timestamp, we're looking at 2021, right? In 32 seconds. What I want to point out is that when I go one more capture forward, what's going to happen here on the time? It's not going to give me the next second. These are not live videos. These are time lapse. It's going to be 4 minutes later. You guys see that? I'm going to back that up. Well, I guess 3.5, close to 4. See? So what I'm saying is, even though we see brightness here, and that's when this, it appears that that's when this started. If I back it up one more, it even kind of appears there also. That's at 19. So if I want to, we don't know what happened 19 from 15 to 19. We don't know when that exactly started by looking at this. You can't. So if we're going to get specifically down to like 8 minutes, if this thing is, if shockwaves are moving at the speed of light or a little bit faster, and to be honest with you, in my opinion, it just doesn't matter. The shockwave is going to hit before we know it. The x-rays are going to hit here before I could come out here and tell you. Okay? So I just wanted to point that out. It just really doesn't, the difference there doesn't matter. Even if it does get here a little bit faster, it could, I don't know. But it would have to be moving faster than the speed of light. Because that's how fast x-rays move, guys. It literally would have to move faster than the speed of light. So that's what I'll say there. So let's just move on from that. I just wanted to point that out because people were asking me, is there things that get here before x-ray? Can it get here faster? When, how fast can we know that this stuff is happening? And that's what, I got like 2 or 3 emails last night about that. And it's a legitimate question. It is. And there very well could be some science out there that proves that stuff gets here faster. I don't know. I really don't. I don't have an answer for you there. My answer to this question is that, does it matter to us, like for what we're talking about? Probably not. It is really interesting if it does get here that quick. It could help us understand other things better. And I simply just don't know. I don't have the knowledge for that. So to answer your guys' question on that, that's what I would say. But X-rays definitely move at the speed of light. It's radiation. It gets here. It's part of the light spectrum. That's why it's moving that fast. So the sun's 93 million miles away, and it takes 8 minutes for that stuff to get here. So if things are traveling faster than that, and obviously it's traveling faster than the speed of light. So yeah. Okay. So now let's go back here to this so I can get back to this part of it. You can see where here in the next hour or two, they're saying that we should be at a G2 storm level, and we could. I'm not saying that we can't. I'm not saying that we won't. I just simply don't. I'm not going to say one way or the other right now. We should start storming here because of CMEs. And if you see right here, look here, they're talking about a 75% chance today that we should see a bunch more M flares. I don't want to say a bunch more, at least some M flares. More, just continuing. And there's like a 35% chance for the next 3 days of an X flare or bigger. So why is that happening? Well, this right here. That sunspot group right there. And I'm going to take you over here to, let's go back over here to, well, you know what? I'm going to show you guys the CMEs first that's been popping off. Okay? This is NOAA's version of the endless spiral model. Top down, inner solar system here, and there's a side cut. The sun's the yellow ball, the earth is the green ball right there. These two are stereo A, the red and the blue. Those are two satellites. Okay, so that's what you're looking at. This over here will show you where we're at currently, and it'll tell us what happened 2 days behind us. And then this model here, it's attempt to forecast out 5 days in advance. Okay, so hopefully that might help you there. I help you understand what we're looking at anyway. So let me run this model and we will zoom in, because this gets really pretty interesting, just to be honest with you. It's pretty cool, actually, if you look at this. I didn't show you guys this yesterday. A lot of the reasons why, because it wasn't even here yet. But did you guys see all that? Obviously, I'm sure you did. So let me just grab the slide bar and we'll just start that over here. You're going to see the CMEs pop off, is what I'm saying. So watch right here where my cursor is. Well, right here. Okay, you see how rapid fire they're happening here? And I know they're kind of small right there, but there's the first one, second one right behind it. Now it's interesting, check this out. This one fires off. Now look how fast the one behind it's moving. Watch it catch up. It caught up right there. See that? Okay, not only did that catch up, there was more fired off. Okay, and then another one. See that one? So there's 4 of them that fired off in a very short amount of time. Okay, when did that start firing? We're going to call it 1:10, 10 o'clock UTC on the 1st. Well, that's probably not even when it started. It might have. I can't remember. We'll start there. We'll start at like 15. Okay, 15, and then was that 15 on the 1st? Yeah. Okay. So within like a day, you get like 4 or 5 of these things just blowing off over here. Okay. Now there are a couple more firing off too. This one just isn't. It kind of shows it. I'm not sure if you guys can see that, but there is a disruption right there. Okay. Now the NASA version shows that this one here a little bit better. So let me show you that one here, and we'll take a look at that one. But there's, obviously when these things fire off this way, this direction, they can reach back and hit us, and that's exactly what's going to happen. Okay. And I mentioned this yesterday, just so everybody understands it. So let me just get that there again. So we'll take a look at that again. See how it kind of, even the spiral model, even you could see it kind of curve back down this way. So why does it do that? Well, let me show you. This is the endless spiral model, right? Same model I just showed you guys, but this is NASA's version. I explained this yesterday. You see how the connection lines to the sun curve back this way? It's because of the motion that we're moving, guys. Okay? We're moving through space like that. That's why this happens. But as you can see, this one here is that little faint one that the other one showed. So that came from a different area on the sun, obviously. So now we've got just multiple ones happening. Now this one gives us our orbital line stretched out in a straight line. And when you see that little disruption right there, when it shows it hitting us here and here and here, that's just saying that this model thinks we're going to get hit, right? Pretty decisively there. Now I don't see anybody. I've watched quite a few channels now today. A lot of people reporting on this. Nobody's saying that this stuff's going to miss us. There's some, difference in opinions on how much and how this and how that, but we will see some effects. Okay. How big they're going to be, I'm not even going to say, because the forecasting has been a little bit off lately. So I don't really want to say something and just for it to be completely, utterly wrong. But you look at all these CMEs. It floors my mind. It just floors me, and it blows my mind that that's what I'm actually looking at there. It's just kind of, yeah. Anyway, I think it's cool. Don't get me wrong, because nothing bad has happened from this thing yet. So, when we get a big CME, the biggest thing we've had happen is an increased aurora. We've had some radio blackouts, actually some pretty significant ones. Okay. When you talk about X flare, you're talking, that's R3 conditions, and you can see, blackouts upwards of an hour on the day side. So whatever side of the planet that happens on that's facing the sun when it flares, you will see some radio blackouts most likely in those areas. And that happens with low-level flaring too, but more so, and it lasts longer when they're larger. So let's go to here. This is Discover data. Again, this is density in orange of the solar wind itself. The purple is the speed. Okay, so what's normal density? 4. But I don't really hold true to that, because I've seen us take huge density hits in our magnetic field, just completely just brush it off like it wasn't nothing. I've seen us take big high speed hits and nothing happened. What do they consider normal for solar wind? That would be 300 to 500 kilometers a second. So when you see this thing get over 500, that means they're saying it's above normal. And you can see where it got pretty fast up here. It got into the 600s there for a minute. Not very long, but at the same time, look, see, when the speed went up, the density dropped. Now, if you think about that for a second, that's really most likely what should happen. Because when things are moving faster, they're going to spread out. They're going to be moving faster and get out of the way. So it's just like anything else. It just kind of gets a little less dense. So we see that. Oftentimes when the speed goes up, the density goes down. And the reverse happens too. When the density goes up, the speed goes down sometimes. Now, when they both go up at the same time, that's when we take hits. Big hits sometimes. But notice when this happened, look what happened up here. The BZ dropped down to -6. It was even further facing south than that. But this is when we were in a geomagnetic storm. So if this BZ had stayed up here, we probably wouldn't have been in any kind of geomagnetic storm. This is very important. We have to understand that this BZ controls a lot. The angle of which our magnetic field is pointing matters a bunch. Okay? If I had to pick one data point to look at, that would be the one I would look at. Because we can take very, very small increases, and if our angle is pointed to the south at the right time, we can take some really good smacks without it being that intense at all. And and we all know that our magnetic field is starting to weaken also. It's in a weakened condition. It's a natural thing that's been happening. And that's another big conversation. But notice how it dropped here too. Guess what? I think we were in geomagnetic storm conditions there. I could be wrong though. We might not have been. But every time we drop down like that doesn't necessarily mean we're going to be in storm conditions. I'm just saying that this one data point actually, to me, seems like it matters more than a lot of others. Okay? So that's kind of what I would say there. Okay, so let's I'm going to go ahead and let that refresh. We're going to get that thing moving here. Hold on a minute here. That thing just quit. Anyway, I'm going to go ahead and just let that refresh. Also, what I do want to do is show you guys the sunspot, because I think that this is really going to be important for you guys to see, because I don't know if I needed to do all that, but okay, whatever. Okay, now this is SDO, all right? This is a satellite that sits out in front of the Earth. Where's the one I want? There it is. What I'm going to do, and I should have done this already, guys. I am sorry, but I am going to show you this. I'm going to start showing you guys this more often. I want to show you guys the location of this satellite. Okay? I think it's important for you guys to understand the perspective of where we're looking from. All right? And all I have to do is come over here to SDO and go to home. Takes me to their home page, and it says, where is SDO? You guys can do this too. Okay? Go hit where is SDO. There it is. This is one look that you get. This eye is always facing towards the sun. Notice how it's kind of twisting? It has to twist to keep its eye on the sun because it's rotating around Earth's axis with us at the exact same speed we are. So it stays over the same area of our planet at all times, but it pivots on its axis and keeps its eye on the sun. It might not pivot on its own axis. The eye itself, the camera will move that way. I'm not sure if the whole satellite turns or not. I can't remember. But if you look at the satellite, you can see it's got a bunch of different detectors and data collection. Everything's on this thing, guys. I mean, there's not just one camera on these things. There's a ton of stuff. They call it a suite, right? But yeah, I think it's a Secchi suite, if I'm correct. I could be wrong. I'm pretty sure Secchi was on stereo A, I believe. I can't remember which one it is, but I think it was stereo A. But anyway, this is what this SDO satellite does. It does this figure 8 pattern all the time. But as it's staying over this same spot on our planet, you got to think that in what? I don't know, let's say 12 hours, guess what? This thing's going to be over here, right? Because it's going to rotate with us. 15 degrees an hour. That's what we rotate at. So as it's moving, this satellite is going to do the same thing, but it's always looking at the sun. So just so you guys understand what perspective we're looking at there. I hope I help people understand that a little bit better. I think I need to do that more often because it's confusing when people say, hey, we got a satellite in geosynchronistic orbit. And for most people, that's just a bunch of word salad. You're probably sitting there thinking, what the heck is geosynchronistic orbit? Well, it's exactly what I just explained to you. It means that this, whatever is in geosynchronistic orbit, it stays over the same part of the Earth as the Earth rotates. It rotates with the Earth at the same speed and stays over the same area. Okay? That's what that means. So, anyway, let's go back here. And this is the sun right now, and this is showing us the sunspots. There are 12 cores here. Was, anyway. I'm not sure if there still is. And it was about 130 kilometers long. Big. That's big, guys. This is a big sunspot. I think it's the biggest one of the year. But you see how big it is. And what makes this so impressive is the fact that the size of it, and what makes it even more impressive is it's not stable. Okay? And what I mean by that is you got positive and negative cores interacting with each other here. They're just all up in each other's business, right? I mean, look at that. It's not like this little lonely thing over here. All right? So when the party's going on, guess what? The disco ball's moving. So there you go. That's what you get there. So, hey, what's up, Tommy? I'll say hi to everybody here in a minute. My brother Tommy right there, and everybody else from the boat, welcome. Hey, Trish. Okay, so that is, what I'm trying to say here is that this is definitely going to be active. This thing's going to be in front of us for at least the next 4 or 5 days. This thing here it's on its way out, but this is what gave us all the flares, the big ones, and the majority of the CMEs. Okay? So, again, this thing was firing when it was over here. It stopped firing when it got here. Then it started firing again when it got over here. So I'm just having a hard time thinking that there isn't something to be said with the Earth-facing quiet theory. I just think there needs to be a whole lot of study done on that and a whole lot of more data collection. It does appear that there is something to that. I can't give you any kind of scientific, hey, go look at this to prove this or prove this wrong or right or whatever. But I would suggest people look into it just to get their own opinion. But it does seem that we might be experiencing that. And I will say this too. I don't think it's going to hold, right? There's going to be times when big ones like this are right in front of us. It's going to fire at us. All right. So don't misunderstand that whatsoever. Please don't. Okay. Anyway, so that is that sunspot. So let me move on to the next thing here. What I'm going to do is show you seeds. This is Lasco C2. And actually, I'm going to back this up because I want you guys to understand this too. I'm going to use this right here, this little crude little inner solar system graphic right here. You see this? This is the Earth. The satellite I'm getting ready to show you is sitting right here, about 1,000,000 miles closer to the sun, always looking at the sun, and it orbits with us around the sun. Yeah, and what you're probably asking, well, what's the difference between that and SDO, the one I just showed you? Well, SDO is here, and I believe it's, was it 38,000 miles? I can't remember exactly what its elevation is, but it's a lot closer to the Earth than what LASCO C2 is. And the other biggest difference is this is in geosynchronistic orbit. So what does that mean? Like I said before, this is the way to show you. This satellite will always stay in this position no matter how the Earth is rotating. Okay? If this satellite, let me zoom in. If this satellite was SDO and sitting right here, it would still be looking at the sun, but it would rotate with the Earth, and at times it would actually be back here with its eye looking at the sun. This right here is the reason. This is what the Earth actually gets in front of the satellite and in between the satellite and the sun on SDO. There is a eclipse season. I talk about it whenever it happens because people freak out when they look up at it and it looks like something's going, blacking the sun out. Well, it kind of is, but it's the Earth. So every once in a while it's the moon too. But we won't go into that one. That's a whole nother talk. But, so when the satellite's back here, sometimes the Earth's in between it. Now, there's a third satellite, okay, that we show you all the time. It's GOES. It's the one that collects the data for this. Okay, why am I bringing that up? You see this spike down where all the X-ray drop out? When GOES satellite is in the position back here where the Earth's in between the sun and the satellite, it cannot collect data. That's why that appears that the X-rays drop out. It can't detect them because it's not in a position to. It can't see it. So just understand that. All right, so that's what's happening with the GOES. That's why this happens. Okay, the Earth gets in between the satellite and the sun. That's really what happens. It can't see the X-ray to detect it. But those are three different satellites, and I know that can be confusing, guys. And I tried to explain it as simply as I could, and I can explain it again in a future day. But just understand that that's what's actually happening between those three satellites. We basically got two satellites that give us our perspective. Okay, GOES does too. That's a third one. But Stereo A over here is kind of over here now. It kind of gives us a side view, just a small bit of one. So I'm going to show you that satellite here in just a second too. That's why I brought it up. But we're going to look at LASCO C2. That is the cameras that are on the SOHO observatory, this satellite. This is the camera suite that's on this satellite. Okay? And again, I know that's a lot to be throwing at you guys. I'm sorry, but there's no other way to say it. But so let's take a look at it. This is on the third. And again, that one there is the one that's going to be that NASA picked up that NOAA really isn't showing a whole lot of. NOAA showed it, but it didn't show it as intense. So you can see, this occulter disc is actually a black disc on the sun. Oh, not on the sun, on the camera. Okay, it blocks the light so we can get a capture at all. But you guys can see, just eruption after eruption. We'll go back to the second. And again, eruption, eruption, eruption. And these are the ones that you've seen on the NOAA Enlil spiral. That's the start of them. So if we look at the first one here, right there, So you got one firing off and you got faster one behind it. They're catching up with one another. When that happens, you get an interplanetary shock wave. When they run into each other like that, they don't actually like run into each other. Positive and positive push against each other, right? So it's really hard for atoms to smash into each other. Okay? That's why, you know, when we talk about the big CER thing that's in the ground over there with the big tunnel, and they move these atoms at really high speeds and smash them into each other. Okay? That's why they have to move it at such high speed. They have to overcome that. And when they do, it puts out a lot of energy. So what I'm saying is that I'm not saying that none of this stuff doesn't collide out there, but for the most part, what you see is that they push away. So that's what causes the shock wave. They don't actually just ram into each other. It's that force of pushing against each other that causes that wave. So at least that's the way I understand it. And that's a very simplistic way to say it. So I'm sorry if I get too simple here, but I really do try to make it so everybody can understand. And when I say simple, I don't mean stupid. Know that, okay? Just know that, guys. I will never, ever think you guys are stupid. Ever. Anybody. I just know that this stuff was hard for me to understand in certain areas of it. And when I, finally felt like I could understand it enough to share it with you guys, I still got things wrong. But I don't regret it, because now I learned and I'm able to help you guys, and you guys can do the same thing that I'm doing. So this is our side view. Check it out. That's that stereo A I was telling you about, right? So there's a CME here. The Earth would be over here, guys. Okay, from this perspective. So just so you know, but that was on the third, I believe. We'll go to the second. And again, see how they're all firing off everywhere, and it's not catching all of them. This satellite seems to have a little bit of data collection glitching, a lot more than what the other ones do. It probably still gets the data. It's just the transfer of that data to us, like through these websites. We just lose some. People have to work to do these things, right? This is somebody's job. So when they don't have the manpower or whatever to make sure that things are up to date, we do get lags in this sometimes. And other times the lag is built in so they can get better resolution to show you. It's out there in space. They can get you an image really, really quick, but it's going to look so crappy because the definition of it. It's just like transferring something through the internet. It ain't the same, exactly the same, but it's kind of the same concept. When you're moving that distance, it's going to lose data. So if you can do it in a slower way, you could increase your definition. You could process it in a way that it gives you a really good looking picture. So that's sometimes some of the delay we get on these tools is caused from that. They don't want to show you something that looks stupid, right? Only they can understand it until they clean some of the definition up they're not really cleaning it up. They're just waiting for more data to come in so they can just give you a better picture. It's simply what it is. So, yeah. Hydrodynamic. I'm going to address that really, really quick. That will happen when it's time for each one of us to happen. We don't do fear here at all. 100%, never, no fear. And I absolutely don't think none of us, that's going to happen to any of us. It's not going to happen today. Well, Stephanie said it. Not today, Hydra. Ain't going to happen. Unless it's our time. And it ain't going to happen from this. Okay, what I'm showing you. We ain't going to die. This isn't like that at all. I'm just showing you stuff that's happening in space and showing you how it can affect our lives daily. And I also show here that, our sun is the biggest driving factor for any kind of weather, any kind of event here on the earth. The sun is a big player in all of it, including earthquakes, all of it. Hurricanes, all of it. So just say, yeah, exactly, Hydra. Yeah, I know. And guys, I don't mean to sound, I don't know, because that didn't offend me, but I know I sound a little intense when I answer those kinds of questions. It's because I fight against that. I don't want anybody coming here in fear, and I don't want anybody leaving my channel in fear. ever. When it's time for us to have to take action, I'm going to say that right at the beginning. I promise you. Okay? If it ever comes a time. And most likely, guys, if we're talking about the SHTF type of thing, I'm not going to be able to get here in time to tell you. Okay? If we're talking grid down type of stuff, most likely, I'm not going to be able to warn you about that. We might have a short time to do it, to tell people, hey, this is coming, that or this, that or that, if we have a big one coming. But that would be here in hours of it leaving the sun. The flare part of that would be here in 8 minutes, and that would be completely impossible for me to get to you. So that's just what I want to say. And, so please just understand that that's, we will never ever be able to come out here and tell you that, hey, we're going to lose our power in 5 minutes. That's never going to happen. It just can't. First off, if SHTF is happening, I'm taking care of my family, and I would hope you guys would do the same. And, that's kind of what I'm saying. But if we've got days to talk about something coming, because I can tell you right now that some of these events that we show have an outside chance of knocking some power out from here or there. So, the biggest thing that we can do is help each other and prepare and do what we need to do. Give me a few weeks warning. You're watching Downtown. You need to finish it. Okay. Yeah, you need to finish watching that, man. That's important, man. But anyway, I just wanted to put that out there. I'm sorry I kind of sidetracked there a little bit, but I think it's important for people to know who you're listening to here. I'm not going to give you fear ever. If we're afraid, we make really bad decisions. So I'm never going to come out here and intentionally scare anybody. Now, I will be 100% real with you. Okay? If I think that somebody needs to take action doing this or doing that, I will tell you that. But I won't tell you that until I need to say it. I'm not going to say, hey, we got a 5.3 percentage chance of having to, run to the store and grab some propane so we can all live next week. You're never going to hear me say anything like that. It's just not going to happen. Now I will say stuff like, hey, this is what's coming. This could happen. Right? That's why we have these things. This is showing you what could happen during each one of these kinds of events. Now, again, if we're talking about like grid down stuff where you really need to get out of Dodge, there's nothing I can show to help you. That's where people like Rip, Alaska Prepper, Marfugal, all these guys that help you guys understand how to prep up. That's where they come in, and they help us. They can't help us during the event. They have to, and Survival Game. I'm not sure if Ilea's in here or not. We emailed a couple times back and forth. I'll be going on her channel. She'll be coming on mine, by the way. They help us prior to the event. It's up to us to decide what we do, right? And that's why I don't tell you guys how to think. I don't tell you guys, hey, you need to think this way. No, I'm not going to do that. It's just ridiculous. How much I need to prep is up to me. And how much you need to prep is up to you. And how much you believe whatever's going on is up to you and me. That's why I show data. That's why, honestly. Okay? I could come out here and talk about a whole lot of other different things. And all I'm going to be able to do is give you an opinion. That's the truth. So, just saying. I'm sorry about that, guys. I really fight hard against that. I'm passionate about just stopping all that fear stuff. I just can't stand it. But yeah, it is what it is. And let me tell you something else here too, guys. It's okay to be eccentric. It's okay to be intense because that's entertaining, right? Especially if it's your thing. It doesn't mean you're spreading fear. It just means you're having fun, and everybody they can see that you're just having fun. And I just hate it when people look at somebody. I used to do it. I used to do the same thing. I used to look at people doing that thinking, man, they're just over here fear-mongering this and fear-mongering that. No, they're not. Most people are just having fun. That's all it is. It's got to be entertaining to watch sometimes, guys, especially when you have like a catchphrase or something that you have and it becomes who you are, right? So why would you not continue to say that? It doesn't mean you're scaring people. Because most people can see right through that. Hey, that's just them being funny and doing this and just saying, hey, look, I got some information for you here. That kind of thing, right? Anyway, sorry. Space weather, Mark. Come on, guys. You got to tell me when I'm squirreling. I'm just saying. I can't do it on my own, guys. You got to tell me. You got to tell me, man. You got to get me in here. All right? Anyway, so we got Aurora. That's what you got. You got Aurora right there, fellers. But this is going to increase as we get geomagnetism. Okay, as these CMEs start to hit, this is going to increase. We got a good chance of seeing some Aurora down this far, mid-latitude. If you start seeing it further south than that, most likely that would mean that we're getting hit with a bigger storm than what they thought, which is possible. Sometimes cracks open up too, guys, in our magnetic field. You know, most people think of a magnetic field like it's, well, I'll show you, as I'm talking about this, I'll show this to you. Okay, this is basically our magnetic field. This is our magnetopause. This is our bow shock. It's where the solar wind or CMEs, plasma, hits our magnetic field. Okay, and what's behind it here, it's called our magnetopause, magnetosphere. Okay, so most people think that it's like a blanket. It's not. There's holes in our magnetic field all over the place. Okay? Cracks open up. Right? So I like to think of it like my grandma used to sit around and knit Afghans. And if anybody knows what an Afghan is, you know they have holes in them. Right? So that's more of what is more accurate in my opinion. Be more something like that. Or maybe like you could think of it like a doily that sits on the table, the end table. How it's got kind of holes in it. You know, it's a little bit more, you know, closed up than that. But there's weak spots in it. There's complete cracks and holes. So in those spots, when we get hit with stuff, geomagnetism comes on in, and that can allow us to see Aurora in places that we wouldn't. You know, there's been reports before of like Aurora down on the equator that, and I'm talking like outside of like a Carrington event, right? So if there's a crack there in the magnetic field for whatever reason, and it gets through, you may see some Aurora down that far for a short amount of time. But what we're talking about here is more of a consistent thing, okay? So, and again, you're going to see it around the poles. Why? Because geomagnetism comes in easier at our poles. It's the easiest way for it to get in here. It's basically because we're almost like a dipole magnet, guys. It's like a bar magnet going right through our planet. You got a positive and a negative, and if you understand magnetic pole lines, they arc out like this. Okay, I can show you a graphic, and I might do that tomorrow. But they kind of do this, okay? And if you look at them, it kind of leaves the north and south just like wide open. So, anyway, we'll just get moving here. I do want to show you, see if we got any. I haven't looked at this yet. I forgot about this. This is the geoelectric field model. This is geoelectric, not geomagnetism. So this is showing you space weather's effect on artificial electrical components, transformers, wires, switches in your wall, all that stuff, right? Anything that's not natural. So you can see how, it kind of picks up and it does its thing here. You'll notice around higher populated areas, it does get more intense because there's more of those kinds of components because population is more heavy. Now that they made this model because they're trying to tie together Well, they know that it's tied together to earthquakes, right? We know this. They're just trying to get more specific with it so they can use it for forecasting earthquakes. That's why the USGS stamp is right there. So, you make Afghans, do you, Vicky? That's okay. Hey, I love them. Yeah, Tommy, I know squirrels over there taking over. I've seen it. I've seen it more than anybody else has, other than yourself, probably. Fee might have seen it more than me, but, you know, or Phi. Sorry. I don't know. Fiona? Phi? Well, I'm just kidding. That's a joke between me and her and you. I know you know that. Anyway, so you got this going on with geoelectricism. And again, guys, the same thing applies. Geomagnetism and geoelectric, it happens at the same time. Okay? Both these models are going to react at the same time. It's just showing you two different things. So this is a good thing because they're going to start using it for earthquake forecasting in the future, I'm sure. So, and again, go check out Ron Tyler over at Emergency Management Associates. Please go check him out. He may even be live now. I don't know. But go check out Marfugel. You guys know this. Go check out Marfugel. I forgot to mention Marfugel last night, and I felt horrible. Adam and Dex have just done so much for me and my channel and for you guys. It's just amazing, and I feel bad when I don't mention them. But anyway, that's what's Marfugel. Now, guys, we'll keep an eye on this stuff that's happening, all right? I'll try to come on here and give you an update if anything else happens. But just know that we have these chances of these events happening, and the percentage and the chance of it happening is increasing. So we are coming, you know, they're talking about a G2 here in just the next few hours. Is it going to mean anything for you or me, like right away? Probably not. You're going to see more Aurora. You could see some electrical issues or some satellite control issues, all these small things. But when the bigger CMEs and stuff hit, if we get one fired directly at us, it's going to mean something different. I promise you. But this is my partner, Tommy. He's in the chat right now under the lifeboat banner right there. We did a live stream a little while ago. I did one with him. We do it every night. No, not every night anymore. We do it from Friday to Tuesday night, 5 days a week. But we're always available, even on our days off. So just know that. It's an addiction channel. I've said that 1,000 times. But for anybody that doesn't know, please come check, not addiction, but just kind of a recovery channel. Addiction recovery, alcoholism, that kind of stuff. No judgment ever. That's the biggest thing I could say to people. We don't judge you. If you're drunk, if you're high, you need to come into our chat. Okay? We don't judge you. We will talk to you. You'll get love right up off the bat. And you know, I'm on, you know, Wages World is on Marfugel's friends tab on his website. And the lifeboat's on there too. And it's because we're positive. And you know, that's why Marv has us there. So it's a really cool honor that he did that for me and trusted me and Tommy enough to put the lifeboat on here too. And it's made a huge difference in our channel already. The people that are coming over, they're getting real help. They're adding to the positivity. And they're adding to the help that we're giving people. So if you guys, please, if you know anybody that's in addiction, if you yourself are fighting it, we can help. Come over here. And a lot of the help doesn't really even come from me and Tommy. It comes from the people in the chat. I would even say that 99% of it comes from the people in the chat. That might be a little too high, maybe 90%. But the real help comes from talking to people that's been through what you're going through. And if you don't know or understand addiction, come over here. Ask questions. It's a call-in show. Or you can just type it in the chat. Our emails are there. What I'm saying is it's an avenue. You don't have to be afraid of it. We don't force anything on anybody. Much like here. We don't judge people. People form their own opinions. People get clean and get sober their own way. We're just there to support that in any way that we can. And I have to say that my partner Tommy's really good at what he does. And I'm telling you guys, the man has a passion for it. He was a heroin addict for 30 years. He went to federal prison for, robbing banks and everything else, guys. And if you were to talk to him today and not know any of that, you would never know any of that until he told you, because he will. He's completely transparent. And that's the thing. That's what we have to be. And that's why, people feel, that's why people are able to get help, and we give it. We do our best. We're not doctors, but we're people that have been through it and can get you at least get you started on something that might be able to help. So, anyway, I just wanted to say that, guys. I'm going to put the link in the chat if I can get back to my chat. I don't know where it's at. Hold on a minute. Back over here. Let's go back. Yeah, there it is. There's my chat. It's like, where the heck is it going? Oh my goodness, where'd it go? Where'd it go? Oh no, Mr. Bill. Anyway, so I'm gonna put this in the chat here real quick. That is the link to Lifeboat. Please come check us out. Please. We're growing and we're helping. And, we gotta, like I said, the crew does most of the helping. We're just there to help facilitate it. And the channel's pretty much your guys' anyway. We try to do what you guys want us to do and talk about what you guys want to talk about. And we are definitely in a complete epidemic when it comes to fentanyl. So, guys, we got to, it's killing our kids. They're making it look like candy now. I mean, how much more warning or how much more in your face do you have to be? They're making pills look like freaking candy. And it's deadly. 36 million lethal doses of fentanyl confiscated within the past few months. It just blows my mind. 300 a day are dying from overdosing. Did you guys know that? Back in the 70s when they said it was an epidemic, only 7,000 people died that year. Now it's 300 a day, and we're the ones that have to be out here screaming about it, because if we don't, it's getting better, I will say. We got to get everybody screaming. So just know that. So more flares coming. Probably. But this Sunspot, we're going to keep an eye on it. Anything else happens, guys, please go check out Marfugal. They're going live here tonight. It'll be awesome to go over and watch them. Most of you guys know who Adam and Dex are. Come check us out over here. Rip, everybody else. So, and I did do all the space weather at the front. So I did want to tell everybody that, because I get hammered on, and I'm trying to get better at that. And thank you for your criticisms, respectful criticisms, all that. So, yeah. Guys, he's got another email too, guys. sober@myyahoo.com. Please check that one out. That's a if you've got an emergent issue, you really need to talk to somebody like now. Look what's happening right here in my chat. Tommy's trying to help somebody. It's crazy. Yeah, and Trisha, we're here. Heck yeah. So anyway, guys, anybody that needs any of that kind of help, please come check us out over there. I really would appreciate it. And you guys are going to get something from it, I promise. So anyway, guys, God bless. I'll see you guys over at Marf, I'm sure. Yahusha saves. And you can drink this Kool-Aid.